Okay, here's a diagram of the region in question. We've got this curve right here, which is y equals the cube root of x. You could also write it this way, x equals y cubed. And the point of intersection is over here at 8, 2, which we can solve by putting 2 in for y. The question is, if we're going to revolve that region around this green dashed line, which is the y-axis, do we use the shell method or the disk method? If we use the shell method, there's a typical shell wall, which we're going to revolve around the green dashed line. We would also need the average radius, which is the distance from the axis of revolution to the center of that shell wall. If we're going to use the disk method, then we need the outer radius, which is the distance from the axis of revolution to a point at the outer edge. And that would be their outer radius. Their inner radius is 0 because the axis of revolution is on the boundary. So here's what that looks like. If we're going to use the shell method, the height of the shell is this 2 at the top minus this distance right here. For every x between 0 and 8 is the cube root of x, or x to the 1/3. So if we subtract that from 2, we'll get the height of the shell. That's why that's the height of a shell wall right there. And the average radius is the distance from the axis of revolution to the center of the shell. Well, that's just x minus 0. So there's the setup of the integral right there. You could distribute the x, find an antiderivative, evaluate from 0 to 8, multiply by 2 pi. That's what you get. Here is the disk method. The outer radius is just y cubed, and we square the outer radius. These disks are occurring along the y-axis from 0 to 2. So the antiderivative of y to the 6th is 1/7 y to the 7th. Evaluated from 0 to 2 is just going to be 2 to the 7th, 1/7, 2 to the 7th, multiplied by pi. Same answer. So there we did it without a calculator. 128 pi over 7. Okay, there you go. Hope that helped. If you have any questions, post a comment.